All right, so this lesson is designed to build upon what you would have looked at and hopefully practice a bit from the last lesson, which is the tangent ratio. And so if you're looking at this and you haven't actually practiced anything from the tangent ratio yet, if you haven't checked your understanding by looking at least a few of the homework problems, I wouldn't bother looking at this yet. Because I'm going to assume you've seen that, because this is so similar to that now that I'm not going to spend much time detailing things that I detailed in the last lesson. So the tangent ratio is a name for the ratio of any right triangle of the side opposite to an angle divided by the side adjacent to an angle. And we saw how we can use that ratio and our calculator to find missing angles and sides of right triangles without actually literally measuring them with a ruler or a protractor. Well, sine and cosine, exact same idea, just different combinations of sides. Okay, so tangent is opposite over adjacent from some particular angle. Sine is opposite over hypotenuse. Remember, the hypotenuse is a key side of any right triangle that we didn't actually use in the last lesson. I labeled it, but we never actually needed that size. Well, sine is always opposite over hypotenuse, and cosine is adjacent to some angle divided by the hypotenuse. But we can use these in the exact same way as tangent and in terms of using the tangent or the inverse tangent to find an angle. Same idea here for sine and cosine. All right, so everything here I've already mentioned. I'm not going to read this out again. All right, so let's just get straight to it. Let's look at these two triangles, and in this case, find the missing, I have a missing angle here I want to find, and over here I have a missing side I want to find. Now, the main difference between this and the last lesson is that in the last lesson, since all we saw was tangent, you never had to think to yourself, how am I going to solve this? In terms of you always use tangent. We knew we were going to use tangent. In this case, you know, the main difference is we have to decide, do we want to use sine or cosine or maybe even tangent? So if I look at this first example for this triangle right here, I have an angle theta I want to figure out. Nowhere does it say if I want to use sine or cosine or maybe even tangent. So that's the main difference. So how do we figure this out? Well, let's look at this angle. From this angle, I know two sides. 10.2 is adjacent to the angle. The side we don't know over here, this is opposite to the angle. But I don't even need that, so I'm just going to erase it. I don't need to know that side, I don't know the side, but that is opposite to the angle. The 10.6 is the hypotenuse. And that was a side I always labeled last day, but we never needed. Now, if I look at this, okay, I want to find angle theta. What do I know? I know the side adjacent to it, and I know the hypotenuse. So adjacent and hypotenuse is cosine. If I look up here again, cosine is adjacent divided by hypotenuse. And so that's how I know now I have to use cosine, because tangent requires me knowing this side here. And same thing with sine. Sine requires me knowing the opposite side. So that's how I know I want to use cosine. So now I can set this up by writing the cosine of theta, I don't know what it is yet, equals adjacent over hypotenuse. So in this case, 10.2 divided by 10.6. And just like before, if I want to find an angle, I need to use the inverse function. I know what number comes out, I don't know what number goes in. And so the way I do this now is I could take 10.2 and actually divide by 10.6, and I'll get some decimal, a little bit less than 1. But why bother doing that when I'm going to go to my calculator anyways in just a moment? And so I just want to, right now, I want to find the inverse cos of 10.2 divided by 10.6, and that will tell me theta. And everything I just wrote on the left-hand side, everything right here, I can just type into any scientific calculator. And so I'm not going to show you, unlike last day, I'm not actually going to show you me typing this in. So again, not cosine, inverse cos of 10.2 divided by 10.6. The calculator, if it's in degree mode, will say 15.8, so that is theta. About 15.8 degrees, or really about 16 degrees. Honestly, we usually actually round angles to the nearest degree because a single degree is so small, so I'll just round it like that. And so the main difference was determining that I needed to use cosine. Once I knew I used cosine, it's no different from what we did before. And the way I knew I had to use cosine was looking at what I had to figure out, this angle, and from that angle, what I knew. I knew the hypotenuse, and I knew the side adjacent to it. Adjacent and hypotenuse is cosine. So don't assume anything before we actually, look at the details. So again, here, I'm not going to assume I'm going to use sine. I don't know. I'm not going to assume anything. This time, though, I know one angle besides the right angle. I know the hypotenuse. X is the hypotenuse. And I know the side right here, 6.1. This is adjacent to the angle I know. This side down here, which I don't know and I don't need to find, is the side opposite to 38 degrees. All right, so from 38 degrees, 6.1 is the adjacent side, and x, what we're trying to figure out, is the hypotenuse. So again, I'm actually going to use cosine again, because again, I have adjacent and hypotenuse. So this time, I say the cosine of, this time I know the angle, 38 degrees, is adjacent over hypotenuse, 6.1 over x. All right, so now how do I solve this? Well, cross multiplying is quite helpful. If I make this look like a fraction, I could go to my calculator and actually decimalize the cosine of 38 degrees, but I'm not going to. I know I'm going to get a very unpleasant number, so I'm just going to cross multiply. And so I want to take the two numbers I know that are diagonally across from each other and multiply them together, which is 6.1, and take that and divide by what's left, which is the cosine of 38 degrees. So I know x is going to equal whatever 6.1 divided by the cosine of 38 is. And 6.1 divided by the cosine of 38 is about 7.7. In this case, centimeters is my unit. And again, really quick. So in this case, I used cosine for both of these. Again, I didn't jump to a conclusion the next one was going to be sine. I just didn't know, but I became quite certain when I paid attention to what I knew and what I was trying to figure out. In this case, it had to be cosine again. All right, let's try two more. Let's look at this one. Okay, I should have the right angle drawn up here, so I'll draw that up there. And so I'm trying to figure out x. Okay, from x, I have this angle, 34 degrees. Well, x is opposite to the 34 degree angle. I can just see that. 9 centimeters here, it looks like it's adjacent to 34, and in some ways it is adjacent to 34, but it's more importantly, it's the hypotenuse. So 9 centimeters is the hypotenuse of this triangle. And so what ratio am I going to use? Whatever ratio involves both opposite and hypotenuse. That is sine. And so I can say the sine of 34 degrees equals opposite over hypotenuse. And I put 9 instead of 9.0. All right, and so that's the hardest part of the question done, I think. I now know which ratio I'm going to use. I know it's x over 9, not 9 over x. And so I want to solve for x. How can I do that? Again, I could cross multiply. But in the end, all I'm going to actually end up doing is go sine of 34 times 9. Right, divide by 1 I don't need. So in the end, x is going to equal 9 times the sine of 34 degrees. I would just type that into my calculator, so I only need my calculator at one time. And 9 times the sine of 34 is about 5.0 centimeters it rounds to. All right, so keep in mind a common mistake here would be to think that 9 centimeters was the side adjacent. But again, the hypotenuse is in many ways the most important side. The hypotenuse is always opposite the right angle. So the adjacent side is actually this side up here, which we didn't know and we didn't need. So always got to be careful with that, right? Last example like this. Let's figure out x. Okay, what do we have? We have an angle here. From this angle, x is the adjacent side. I know it's not the hypotenuse because the hypotenuse is right here. This is the hypotenuse right here, which I don't know and I don't need, so I'm not actually going to label it as long as I know that's the hypotenuse. So from 31 degrees, the other side, that I actually know, is opposite to it. All right, so what ratio am I going to use? That involves adjacent and opposite. That has to be tangent. And so now I know I'm going to use a tangent ratio. So the tangent of 31 degrees equals, make sure I have my fraction the right way around. It's always opposite divided by adjacent. So in this case, 3.6 divided by x. All right, most important part is done. I have my ratio figured out. I know it's tangent. I have it set up, 3.6 over x. Now I can solve for x. Again, fastest way, cross multiply. Go 1 times 3.6, divide by the tan of 31. So x is going to be the same as 3.6 divided by the tangent of 31 degrees. Which, if you go to your calculator, is about 6.0 centimeters. And there's my answer. So while I'm doing these pretty quickly, I'm hoping once you have your ratio set up, you can do it quite quickly as well. Really, for all of these, there's really just 3 types of questions. There's finding an angle, and then that's one way. And then when you're finding a side, you either have your variable in the denominator or in the numerator. That's it. So there's not a lot of variety here. So I'm hoping we can do this quicker and quicker each time. So for my last problem, I want to find the area of this particular triangle right here. So what's the area? First, let's remember the area of a triangle. Area of a triangle is base times height divided by 2. Well, the base, I know, is 10. The height is what I don't know. The height is the distance straight up and down from the middle. That's my height. Okay, so really, this question is not so much about finding the area necessarily as it's really about finding the height of this triangle. Once I have the height of this triangle, I have a bit of, this now becomes grade 7 math. You know, finding the area of a triangle is grade 6, grade 7 math. So really now, what's the height of this triangle? So how do I figure this out? Let's look at this triangle here. The triangle I gave you, this is not a right triangle. There's no right angle here, but it is an isosceles triangle. The word isosceles means that 2 sides are the same length. So that means I can see that these 2 sides here are the same length, which means these 2 angles right here must be the same. And so I actually can now know what each of those angles are because they have to be the same, but they have to add up to 40. That means each of these must be 20 degrees. In fact, I'll just write one of them down. Because now, if I look at this triangle right here, I have a right triangle that I can now work with. So if I look at that triangle right there, what do I know about this triangle? There's a 20-degree angle there. The height is what I'm trying to figure out. The distance from here to here is not 10, it's half of 10, it's 5. So this is quite messy, so I'll clean this up in a moment. But now I know how I can figure out height. I need to look at just half this triangle. So let me just clean this up then. And make it a little more neat. So now I know I'm paying attention to just this. So there's my height. This is 5 centimeters. And I don't need that 40 anymore. I need to know this is 20. All right, so how can I find the height? Well, from the height, you know, this angle of 20 degrees, I can see the height is adjacent to 20 degrees. And the 5 centimeters down here is opposite to the 20 degrees. So I need to use the ratio that involves adjacent and opposite. What's that? That's the tangent ratio. So now I want to use the tangent ratio. I can say the tangent of 20 degrees. Again, I'm just looking at half the triangle right now. And that allows me to work with a right triangle. Right? If I don't have a right angle in my triangle, I can't use anything we've learned about the last few days. The tangent of 20 equals opposite over adjacent, in this case 5 over the height. And now I'm going to be done really quickly because cross multiply, height is going to be the same as 1 times 5 divided by the tan of 20. So height equals 5 divided by the tangent of 20 degrees. Go to my calculator. 5 divided by the tangent of 20 degrees is about 13.7 centimeters. And so now I can take that and put it back into my equation because I already knew, right from the start, I knew the base. So now I know the height of this isosceles triangle is about 13.7 centimeters. I always knew the base of the triangle was 10 centimeters. And so let's just finish this off now. I can say, therefore, the area is base times height divided by 2, or actually in this case, I'll say 10 times 13.7 divided by 2. There's the base. There's the height. And I get about 68.7 about square centimeters. Although to be honest, I don't really care about the number 68.7. I don't even care about the area of the triangle. I care about that we understood how to get to it. In this case, we had to break up this isosceles triangle in half, figure out how that, you know, the measurements, some of these measurements got cut in half to bring it back to a right triangle, to find the height, to eventually find the area. All right, So with that said, I'm going to stop the video.